Alright, next subtopic is about projectile motion. Okay, now here I have posted here, alright, one example of projectile motion. Alright, so this type of motion, you can see, okay, when a grasshopper jumps, right, or a long jumper, right? Meaning, they will start, okay, on the ground, and then when they fall, they will fall back on the ground. Meaning, the starting point and final point same level. All right. Now, so what are we going to use, okay, to analyze the motion, right? So basically, right, just recall back, okay, recall back from kinematic equations, right? We have x equals to okay, x final equals to x initial, okay, plus vi t, okay, plus half a t squared, isn't it? All right. Now, here it is not only x component, we also have a distance along y component, isn't it? All right. So we also have yf equals to yi, okay, plus, okay, v, okay, ni vix here, okay, plus v ni viyt, okay, minus half a y t squared, okay, ni ax. Okay. Now, what's the difference? Now, in projectile motion, right, finally the ball will back on the ground, isn't it? Right. So basically, okay, we can say that, okay, the motion here, okay, is under the influence of gravity. All right. So all these under influence of gravity, where the acceleration here is equals to ay equals to negative g. All right. So we can say that ax totally equals to 0. Alright. So therefore, okay, the equation here, alright, can be simplified. Okay, can be simplified where we have, okay, y final, okay, equals to y initial, okay, plus, okay, viyt minus half gt squared. Right. So kalau I replace a equals to negative g, it will be like this. Alright. Okay, so for position along x, okay, so here we have x, okay, final, okay, equals to x initial plus, okay, v I x t, alright, sampai sini je, because x equals to 0, alright. See the first equation. Now the second kinematic equation, let's say I choose v equals to vi plus at. Right? So in projectile motion ataupun in 2D motion, because projectile motion is also one type of 2D motion, two-dimensional motion. Alright. So along x component, it will become vx equals to vxi, okay, plus axt. Alright. Now, since ax equals to 0, so dia akan jadi apa? Okay, v final x. Okay, vx final equals to vxi. Alright, so ni v final. Okay, vx final. Okay. Alright, how about y component? Alright, so we have vy final equals to vyi plus ayt. Alright, so this one will become vy final equals to vy initial, okay, minus gt. After I replace ay equals to negative g. Alright. The last equation, okay, we have v squared equals to vi squared, okay, plus, okay, 2a delta x, right? If you still remember this equation, okay. So along x component, dia akan jadi, okay, v final squared equals to along x component, it will be vx final squared, vx initial squared. Alright. Since ax equals to 0, alright, so we have vx final equals to vx initial. Alright, so you can see that the equation here dia sama, okay? Okay, yang ni, okay, sama dengan yang ni. Alright. Okay, next we have along y component, we have vy final squared equals to, okay, vy initial squared, alright, minus 2g, okay, delta y, okay. So basically, these are the 5 equation kat sini. Alright, so we have 1, okay, 2, okay, 3, and then we have 4 and 5. Because yang ni sama, yang hashtag hijau ni sama, right? Okay, so these are the 5 equations that we are going to use in projectile motion. Okay, regardless what type of projectile motion it is. Okay. Now, back to this type of projectile motion. Now, here the object land on the same level. Alright. So, okay, let's point out. Okay. Now, kalau dia land at the same level like this, we can say that the total displacement, okay, ataupun y final equals to y initial. Okay. So, delta y equals to 0. Okay, kalau dia, meaning that if the projectile motion is at the same level, right? Okay, now here you have that the motion diagram here looks symmetry, right? Okay, looks symmetry, meaning okay, another point that you need to know is that if it takes in order to reach maximum height, okay, in order to reach maximum height, okay, katalah dia ambil waktu T1, okay, and then because it is symmetry, it will take another T1, okay, to go down, alright. So therefore, the total time is 2T1. Okay, so ini macam kira shortcut lah untuk you nak cari apa? Untuk nak cari total time in air. Alright. Okay, next thing that you need to know, alright, for this type of projectile motion, okay, at maximum height, okay, apa yang zero? Okay, Vy equals to 0. Okay, Vy equals to 0. How about Vx? Okay, so Vx akan sama, okay, throughout the motion. Alright, so let's say you have like this. Okay, so ini katalah initial velocity, alright, Vi. So ni kita ada Vix and we have Vy. Right, so let me draw it properly. Okay, so let's say you have, okay, right, okay, so ini Vix. Okay, katalah you ada ini katalah vector initial velocity Vi. Okay, so this will be Viy. Okay, ini adalah Viy. Now, at any point akan ada velocity, isn't it? Right? So we have Vy and Vx. Okay, dekat sini pun kita ada Vy and Vx. Now, at maximum height here, okay, only Vy dekat sini yang sama dengan kosong. Alright, Vx will be equal throughout the motion. Alright, Vx sampailah dia jatuh Vx. Okay, that's why dia correspond dengan equation 3 dengan equation ni tadi. Alright, so Vx final equals to Vx initial because the horizontal component of velocity maintain, okay, will remain constant from the starting point until the final point. So Vx remain constant. Yang berubah ialah Vy. Alright. So how Vy change? Alright. So as the ball, okay, rises up to the maximum height, Vy akan decrease. Okay, let's say here you have 20 meter per second. So Vy akan decrease sampai dekat sini dia 0. Right. So bila dia at the other side, okay, bila nak turun balik, alright, so magnitude dia akan bertambah. Okay, magnitude akan bertambah. Okay, and one thing that you need to know is that at the same altitude, okay, same altitude, we will have same magnitude of velocity. Alright, same magnitude of velocity. Alright. Okay, meaning that, okay, as I have mentioned in free fall, okay, dalam free fall sama je, kalau same altitude, dia akan mempunyai magnitude yang sama. Kalau dekat sini 10, dekat sini pun 10. But provided that sini mesti negatif lah because it is going downward, isn't it? If here is 20 meter per second, then at the other side will be negative 20 meter per second. Right? So we can make this assumption, okay, if the motion diagram is symmetry. Nampak macam symmetry, isn't it? Alright. So in the next slide, we are going to be more specific. We are going to look at example of this type of projectile motion.